space-time and the present universe. I'm so sorry. So this is basically a pictorial representation of what Earth is distorting the space around it. It is curving the space-time around it, making it like this. And whenever you hit a cricket ball, it follows a parabola because of the geodesic equation that Einstein introduced. It follows a geodesic because in a curved space-time, parabola is the path which a cricket ball should follow while you hit a ball. The genesis of theory of relativity. So Einstein himself stated that Galileo was the author of principle of relativity. Einstein simply provided a revision. In the spring of 1905, a storm broke out in the mind of Albert Einstein. At least that's how Einstein himself described it. And the storm of that thinking was the special theory of relativity. According to the then accepted principles of the classical physics, light needed a medium to propagate, which scientists speculated as ether. But Einstein told the world that the whole idea of ether was unnecessary. The speed of light in a medium is constant relative to that frame. And this is the first postulate of the special theory of relativity. And what Galileo and Newton missed was that they couldn't figure out the absoluteness of time. They said that time was absolute, but in fact, time had to be relative in special relativity. Next slide. Simultaneity is not absolute. So basically, according to the old existing theories, we used Euclidean geometry to express our ideas. So 2 पॉइंट के बीच के सबसे शॉर्टेस्ट डिस्टेंस एक स्ट्रेट लाइन होता था. बट जैसे ही ये नया आइडिया है रिलेटिविटी में, टाइम हैज टू बिकम रिलेटिव. So if a frame is moving with a relative velocity with respect to another frame, they will lack simultaneity. The events which are simultaneous in the next frame are not simultaneous in the moving frame because it is traveling with some relative velocity. And it was explained by the Dutch physicist Hendrik Lorentz through his mathematics on Lorentz transformation, in which he challenged the absoluteness of time, and time had to become relative in this special relativity. Next slide. So basically, when you rotate a vector, this is the angle when you rotate it with alpha angle. So basically, the coordinates transforms to this. And this is the mix, and the new coordinates are restored according to the old coordinates when you apply cos A plus B and sin A plus B in that formula. And but in rotation, the coordinates are invariant. X prime square plus y prime square plus x prime square is equal to x square plus y square plus z square. Now next slide. So this is Lorentz transformation. As I told you that time had to become relative in the special theory of relativity. So there was this Riemann geometry, according to which Hendrik Lorentz formulated this Lorentz transformation. Next slide. This is the short form of Lorentz transformation where 1 by 1 minus v by c square can be written as gamma. So this is the short form, and this ct square prime minus x square prime is c square t square minus x square, because the speed of light is constant according to the special theory of relativity. Next slide. Length contraction. So another startling implications of the special theory of relativity was this concept called as length contraction. Whenever an object is moving with some relative velocity with relative to a frame which is stationary, then it is length contracted, i.e. it becomes shorter in that frame when observed from a rest frame. So this is the equation, proper, where L0 is the proper length, L is the length in lap frame, and as dt tends to 0, as time becomes relative, distance is also shortened, like evident here. Next slide. Time dilation. So I explained about this time dilation, that everyone will have his own perception of time according to special theory of relativity, and this was even proven. Gravitational time dilation was even proven through experiments from the plane, where there were slight differences from some microseconds deviating from the original slide. Basically, Einstein had this thought that if you are still and there is a train and you are situated at the middle of a train and two lightning bolts are simultaneous, so it will be simultaneous for the person on the train, but for the person who is stationary will have it deceived because he is moving towards one and away from the other, because light is constant, speed of light is constant. Next. Light cone. So basically this is the pictorial representation what Einstein said that the past may have not yet may not have yet existed, the present may have not yet began, the future may not yet be. So my friends, time is nothing but a stubborn illusion, however persistent. So this is this region which is this. This is the future, this is the present, this is the past, and everything elsewhere is what is elsewhere, which is not there in this present, future and past, which events which are not taking place. So there was a theory which was called tachyons, according to which particles faster than speed of light can happen, but that was an anomaly. It was just a mathematical anomaly because that will break time casualty. Like मैं किसी को मार रहा हूँ और उसे चोट पहले लग गई, मारा मैंने बाद में. That is the theory of tachyons. तो ये लाइट कौन था मैंने राइट? E equals mc square. So through this, whenever something is stationary and something is moving with relative velocity, so both will have their unique perceptions of time. So each of them are justified in claiming that their clocks are correct. How to resolve this paradox? This paradox was resolved by this famous equation in probably most of physics, E equals mc square, which clearly states that energy and mass are different manifestations of the same thing. And through this equation, Einstein resolved this paradox. Energy and mass can be interconvertible by a factor which is called the speed of light. So this is the basically Newton idea was x, y and z coordinates. In Einstein's relativity, there is another coordinate which is called as time axis. And energy is one component and momentum is cpx, cpy, cpz. And so if I put p is equal to 0, I'll get the equation E is equal to mc square. And when mass is 0, I'll get the equation of a photon which is E equals to cp. My next slide. General relativity. So whenever an object is under free fall, it is weightless, as predicted by Newton's equations. No one understood the science beyond it. Newton wrote in his Principia, the moon is held in the orbit of the earth because it is tied by some mysterious thread. And this young scientist, Albert Einstein, said that no band-aid pouches will fix Newtonian gravity. I have to invent a mechanism for that. In the special theory of relativity, the problem was that it could only account for accelerated motion, and it could only account for constant speed motion, and the world is moving with acceleration, and it had no account of gravity into it. So then there was this thought experiment which Einstein had, which Einstein called as one of the most beautiful thoughts of his life. So when a man is accelerating downwards, he is under the influence of gravity, he is weightless while he is accelerating downwards. Now Einstein thought that what would happen if the man is now in outer space with the spaceship accelerating upwards, and the conditions were identical, like 9.8 meter per second square was the acceleration due to gravity. So the conditions were identical, but the problem was in the Earth's frame, if you shine a light standing here, it will go straight, rectilinear propagation of light. But in the spaceship, the light would become a little deviated. So this strictly violates the principle of equivalence. So Einstein reasoned through this that maybe it is the trajectory of the curved spacetime which is making the light deviated a little bit. And this was when Einstein found the nature of gravity. Gravity is not a force according to Einstein's general relativity. It is a distortion of space and time. And this general relativity was proved through the fact that gravity bends light. During a solar eclipse, scientists again and again tried their Einstein's general relativity equations, and not a single deviation has been observed till now. So Einstein's general relativity holds good. This is a geodesic equation where Galileo said that if there is no force acting on a particle, it will not accelerate. Einstein added some Christopher constants and did some approximation, and this grad phi. It is this is basically acceleration, phi of gravitational potential. So this equation was restored through Einstein in this manner. Now next slide. Now Laplacian of V is equal to 4 pi g, and this is the density. So when Einstein estimated this also, it was approximately coming out to be as predicted by Newton's equation, g m by r, which is the gravitational potential. And Einstein's Field's equation, this is called the Einstein tensor, and this is called the curvature tensor. So basically, if you take the flux of this tensor, which is written in this it comes out to be 0. Now, black hole. Since all of you are interested in black hole, I'll tell you what a black hole is. Stephen Hawking argued that if general relativity is correct, then these objects must exist. So what is a black hole? To a star more than 3 times the mass of the sun, when it undergoes huge gravitational attractions, eventually overcoming all the electromagnetic radiations on it, basically the general concept is that gravity is weaker than electrostatic force, billion times weaker. But this is a special case. When the star eventually collapses, becoming hotter and hotter, denser and denser, it eventually becomes smaller, then it becomes again smaller and denser. Then we get a point in the space which is called a space-time singularity curve, which is a region of space where nothing, not even light, can escape. In other words, black hole. Next slide. So this is the demonstration of what happened after Big Bang. So Stephen Hawking's thesis was basically that our universe was born from a black hole, because the universe is continuously expanding. If you throw a ball upwards, it will eventually come downwards due to the effect of gravitational pull. But the universe is continuously expanding and accelerating more and more. So this is what the stars were formed, the galaxies were formed, and this is all condensate. It is rendering black hole. This is a picture of a black hole where these are the jet particles. This is the accretion disk, and inside it is the event horizon. So basically, to explain a singularity inside a black hole, where Einstein's field equation also fails, because it is quantum mechanically tiny and relativistically heavy. So we need a unified field theory where we can describe both of them, general relativity and quantum mechanics. We don't have that theory yet till now. And that's right. So this I have told you that the chances are that eventually a star can become a black dwarf or a white dwarf, or it can become a black hole. But I told you the criteria. This is basically that pictorial representation which I just told you. And next slide. So event horizon, like I told you that event horizon, nothing can escape from the event horizon. That is the thing. Nothing can escape from the event horizon due to immense gravitational effects. And this is the accretion disk. Accretion disk is basically when the elusive particles are thrown inside a black hole. So nothing can eject a black hole once it enters the event horizon. If it enters the accretion disk, it can escape. But after entering the event horizon, nothing can escape. And relativistic jets are the particles which are ejected from the black hole during this process. The black hole eventually vaporizes in this process. Next slide. Deciphering the image of Sagittarius. So this was a black hole basically. Stephen Hawking bet with Kip Thorne was that it was not a black hole. This could have been the proven his theory right, but since he was a scientist, he bet Kip Thorne that this is not a black hole, and it turned out to be a black hole. And the features I will explain on next slide. So this is the observed star position, but when the gravity is immensely strong, eventually the light bends, and a person who is observing this will observe the star like this, but actually the star is here. So this is about dark energy, which I told you that the size of the universe is accelerating more and more. As Newton said in his Principia, absolute true and mathematical time of itself flows equitably without relation to anything external, time and space absolute. But Einstein's comment on this was the deity endures forever, existing every duration and space. So basically Newton is saying, God, I have no idea about space and time. So the universe is continuously expanding. This is the basis of dark energy. So we hypothesize that there is something which is filling the space, which is there in 75% of the space. Due to which the universe is continuously expanding.